Hello parents and students, welcome to my introduction to the Essential Guide to Algebra 1, written by the author myself. Right, so who takes Algebra 1? This whole clip or this whole lecture series has been dedicated to grade 6 or 7 who took pre-algebra class already at school or master prep already, and who wants to preview Algebra 1 before school year. So probably either grade 6 or 7. And this is going to be a good materials for revisioning Algebra 1 after school year, right before going on to geometry. Or probably for those of you who have been attending some South Korean middle schools and moving on to the international schools or boarding schools, junior boardings. Right. So that being said, let me talk about the difference or comparison between the Algebra 1 versus Korean math. So first off, Algebra 1 takes about the first semester materials in the South Korean middle school curriculums, but except probably the 9th grade. And we call it like middle school, the 3rd grade, right? So except 9th grade, this contains a lot of materials, the common materials between the first semester of every year that you can find in the middle school year. And the whole class, the Essential Guide to Algebra 1, talks about the core concept explanations, and I go over all these problems as a walkthrough. So I explain all those concepts and how to solve those problems in a multiple detailed perspectives. And of course, we go over skill practice for revisioning. So you gotta first solve skill practice on your own and try to see what's up. All right, so what is so special about this Essential Guide to Algebra 1? This is gonna be compact and precise, totally dedicated to how you should learn Algebra 1 in a very short time manner. So this is exactly what you need to learn in Algebra 1. And at the same time, it's going to be a little bit more advanced than regular Algebra 1 class that you might find at school year. So this might be corresponding to probably honors Algebra 1. And at the same time, this is going to be a good concept revision for people who are prepping up for math competitions such as like MATHCOUNTS and AMC 8. And Algebra 1 does talk about a lot of stuff, linear equations, proportional thinking, quadratics, a little bit more of statistics. And of course, like they do talk about polynomials, but we're going to learn about a lot of stuff about the number and number senses. Pretty much, I would say, the extension away from the pre-algebra. Right, so this is going to be the tips for taking the Essential Guide to Algebra 1. First off, I'm pretty sure that most of you are taking this lecture without any prior experience about note takes. So please prepare a 3-color pen and highlighters and color your notes and color your book with lots of colors, okay? So this is gonna be a good material. This is gonna be a good time. In fact, it's gonna be the first time, I would say, you ever note take and practice note takes. It takes some time, it takes efforts. You gotta practice with it, right? And the second thing is that the core concepts are, again, as I mentioned, it's a linear equations, proportional thinking, quadratics, and inside that quadratics, you gotta be able to factorize those quadratic equations and expressions, and you gotta be able to perform the vertex form, completing the vertex form at 1 knot. So make sure you master all of these. And last but not least, take all lectures, please. Take everything until the end so that you are not going to have any gap, right? Please take every lecture and finish the whole lecture so that you can come back in the later on. But I don't want you to stop in the middle. Please finish all the lectures so that you can finally say, hey, I'm done with Algebra 1, right? So that being said, I'm going to follow through you guys along your successful journey on college preparations. So I call it as end-to-end. I prepare from pre-algebra, I go all the way to calculus. I'm going to follow after you guys, but I'm going to help you too. So we go together and I shall see you in the class. Hey everyone, welcome to Algebra 1, the first class. Right, so we're gonna use my textbook, and I'm gonna begin from chapter 1, topic 1, the expressions and whatnot, and we're gonna cover just 3 questions. Okay, we're just gonna cover 1.1 and 1.2, and probably I'm gonna be ending with 1.2. But as you can see from this book, you can see that there are a lot of spaces, like empty spaces out there. Well, those empty spaces are to be filled detailed with the notes that I'm going to write down, right? So 1.1, we just jump onto mathematical expressions. Now, if you look at mathematical expressions, well, I wrote down something called variable and constant and all those terms that are added by those terms, like the multi-term expressions and whatnot. The very first thing that we have to remember is the difference between the variable and the constant. So let's just gonna hit the variable and the constant. Now, as I wrote down on my book, I wrote down the variable is a placeholder. It doesn't have to be X, it doesn't have to be A, it doesn't have to be Y, doesn't have to be any letters, but it's not just constant term, right? So I just used the term, something called constant term. Now, constant term is a term that does not change. So for an instance, normally when we refer to certain expressions, well, there's something like X plus Y and X plus Z and whatever. Like we got lots of expressions out there. There's some letter expressions and there's some number expressions, right? So the letter expression is normally a variable. It's just a placeholder, right? So it can be replaced with any different number, I would say, but the constant term, as the expression suggests, is always there. Okay, it's an invariant expression. It's something that does not change, right? So that being said, we're just going to move on to number one, and as you can see from my style of teaching, I usually write down a lot of stuff, and I give you I present you with lots of stories. The reason why I have this storytelling techniques is because I need to finish this Algebra 1, which is usually 1 year worth of a subject. Well, I have to finish it within just 40 to 30 lectures, which means that, roughly about 30 hours in general. Now, in order to finish that within 30 hours, I need to explain it quite fast with lots of examples. So I usually say walk through. So we're gonna walk through number one, right? So here we go. If you look at number one, we got A and B and C, and each of those A, B, C, well, we have 3 different expressions as you can expect. Now, if you see the phrases on number one, we get something called evaluate, right? So let's just try to write down, underline evaluate, or I want you to use the highlighter to literally highlight the evaluate, and that means that normally when you see the phrase evaluate, you gotta plug some values, right? You gotta plug some X values. You gotta plug the given values. Plug given values. All right, so we have this evaluate, and we're just gonna move on to A, and A on top of, alphabet A, the subpart of this questions, I want you to write down rational expressions, okay? So we got something called rational expressions, and rational expression means that an expression that can be written as a ratio. It can be written as a fraction, right? So we have X plus 12 divided out by X, and here's one important thing that I want you to literally see. Well, how many terms do we have on the numerator? Well, we get 2 terms on the numerator, but what about the denominator? Well, this term is, right, the expression that sits underneath the little bar that you see, the horizontal bar, is going to be called as a denominator. We get only 1 term. Right, so we get only 1 term, and I want you to group all of these and make some kind of heart shape and break that heart, right? So I want you to break that heart and see what's up. We get X over X, and we get 12 over X, and normally this is fine. Can't do it reverse. What I'm saying is that if I have just a single term on the numerator, if I have multiple terms on the denominator, I'm not able to do that. All right, I'm totally out of the leagues. But however, for this expressions, yes, we got 1 single term, and I can actually consider this as a single term and just group it out and break it apart. Right. So here's what's up. X over X is just gonna be 1. Okay, just gonna be 1, and 12 over X, as you can see from this example, well, it says X equals 6. So in other words, I gotta plug that X value of 6. But the problem that we face is that a fraction will turn into an integer, and I think that's the most important ideas in this part. So here we go. 1 plus 12 over 6, and that becomes 1 plus 2, and that becomes 3, and over here, I want you to write down some stuff as a good solid note, so that when you revision this, you guys can actually say, oh yeah, that kind of makes sense, it's a good revision note. So here we go. 12 over 6 turning into an integer. That's something that is special. And I didn't even write down in my solution manual. All right, so there's no special notes that I wrote down in this solution manual, which means that this is the reason why we have the lecture series right now. I'm having walkthrough and I'm explaining a few more stuff, right?
So 12 over 6 equals 2. It means that 12 can be expressed as 6 times 2. So here we go. Let's just try to use some kind of a star mark. 12 over 6 equaling 2. It's quite important in terms of a skeleton. A over B equals C, or let's say K. Okay? Let's just try to say K. Normally, fraction stays as fraction. Think about it. Like 3 over 2, just going to be a fraction, right? But 4 over 2 can actually be simplified into 2. Now, in what basis would that happen? Well, I would say 12 equals 6 times 2, and I can say that A equals B times K. There are multiple ways of explaining things. 6 is going to be divisor of 12. We say, oh yeah, 6 is a divisor of 12. But at the same time, 12, the numerator expression is going to be a multiple of the denominator. So 12 is a multiple of 6. Now, the reason why I'm giving you a little bit more of a stuff than the usual tutors and all the other people are teaching compared to what they're teaching, well, I'm giving a little bit more because I want you to get prepared, not just for Algebra 1 at school, but I want you to get prepared for MATHCOUNTS and AMC 8 and all those middle school competitions that you are taking, right? So we got 12 being a multiple of 6 and 6 being a divisor of 12. That's basically when we get a fraction turning into an integer. Okay? Right, so that being said, A, we just hit rational expressions. I talked about the single denominator. I talked about some certain algebraic expressions. And when you see A equals B times K, it means that A is a multiple of B. Or we can say that B is a divisor of A. All right, so let's hit upon 1B, okay? So let's just go on to 1B. And see what's up, right? 1B. All right, so right underneath or right above that B, I want you to write down something called exponential expressions or power expressions. Here we go. So this is going to be exponential expressions, or we can say power expressions. Now, this is going to be dealing with some kind of vocab, right? So first off, I'm going to write down some fancy stuff saying that, oh yeah, we got certain circular block, and I usually call Mr. Circle, and we got some triangular block on top of the exponent. So we got this little circle out there that looks like some kind of a cookie. Well, that particular stuff is going to be called as base. And normally, not just in Algebra 1, but also in Algebra 2, or probably algebra, like the pre-calculus, we usually have base being positive. Doesn't have to be positive though, but it's going to be, like we're going to set base as positive. And we're going to see certain cases when base is not positive too. But base is going to be a real number that sits inside here, and we call that particular the triangle that you see right there as something called exponent, right? So we usually call this as an exponent. And the whole expression, right? The whole expression is going to be power expression or the exponential expressions, right? So let's just try to look at our questions right here. We get 3x squared. I actually, read it as 3x squared, right? Again, 3x squared. It's one way of reading this expression, or we can actually say 3 times x to the power of 2, right? So the whole thing is that the power expressions. And what does that mean? It means that x is going to be multiplied how many times? 2 times. That's right. So it's going to be multiplied twice. So we get 3 times x. So, right. All I need to do is just to do some kind of simple math, the mental math, so to speak. And we have 3 times 6 times 6. And let's just give it a go. What's 3 times 6? It's going to be something like 18, right? And we multiply it out like this, and we get 108. Or you could have done like 6 times 6, which is going to be 36. And 36 times 3 is going to be 108. So we end up getting those results. And we just have seen those power expressions, right? So what about like x to the power of 3? Hey everyone, we're going to begin skill practice starting from number 1 all the way to probably number 8 that we have. And we're going to finish this whole skill practice within 1 lecture. So here we go. Skill practice number 1. Okay. So we have skill practice number 1 on page 56. I want you to look at page 56. And A and B, let's read the question. Suppose A and B are directly proportional. If A equals 10 and B equals 24, what is A when B equals 6? Right, so direct proportion. Check this out. Direct proportion. We get A over B, which is going to be a certain fixed set of number. That's going to be invariant, or we usually call it as a constant of variations, constant of proportions. But hey, we get 10 over 24 has been given to us, and I just need to set this as equal to A and B equaling 6. So A and B equaling 6 like this. So that means 60 equals 24A. So eventually A equals 60 over 24. So you can cross out all those values by taking out those, I would say, first 12. So if you take out 12 and 5 and 12 times 2. So you can cross it out and we get 5 over 2. Now we move on to number 2, okay? We move on to number 2, and by the way, this becomes the answer. 5 over 2 becomes the answer. We look at the other one. X is inversely proportional to square root of y. Got it. So x times square root of y equals a fixed number, because everything in number 2 is going to be inverse proportion, okay? These are inverse proportion. Remember that when you see the phrases about inverse proportion, you always have to multiply and get certain product, okay? Now, x has been quadrupled. X has been quadrupled. X has been quadrupled. Now, what will happen to y? So I would like to call it ky, to maintain the same number, So I need to maintain the same possibility. So in other words, this should just be x times square root of y. Right, so we can probably cross out some x's, and if we cross out some x's, well, we end up getting 4 times square root of k times y equals square root of y, and 4 times square root of k times square root of y equals square root of y. So 4 times square root of k equals 1, and I can tell you that square root of k is supposed to be 1 over 4. So k is supposed to be 1 over 16, and it means that we need to divide y by 16. So y is divided by 16, and hey, that's going to be the answer for number 2. Okay, so we saw the direct application of definition. I'd like to move on to number 3, and from number 3 all the way to number, I would say roughly about 5. They're typical questions. They're not word questions, except number 4. But anyway, we move on to number 3 though. So if you look at number 3, it says x squared and y squared are proportional, directly proportional. Got it. So x squared and y cubed are directly proportional. So let's just try to write down some invariant like this, okay? And again, when I write down those like triangular block, in this case, this is going to be, again, constant of variation. Or you can call this constant of proportion, okay? Constant of proportion. Okay, so we have these two numbers, and x equals 2 and y equals 3. So x equals 2 and y equals 3. So those are 4 over 27. That becomes a number that has been, fixed, I would say, invariant. Now, what is y when x equals 3? Got it. So what is y? Y cubed when x equals 3, so 3 squared. So in other words, 4 over 27 just has to be equal to 9 over y cubed. Right, so we're solving for 4 over 27 equals 9 over y cubed. And in fact, this would be 4y cubed equals 9 times 27. So y cubed is supposed to be 9 times 27 divided out by 4. All right, so how do we get y though? Well, if you see these y expressions, well, we can actually simplify, and I want you to write this down as notes. Okay, so this is going to be extra note on the third root of something. Y is supposed to be third root of 9 times 27 divided out by 4. And let's just try to break this down. Third root of 3 squared and 3 cubed, and there we have 2 squared. Okay. these little 3 cubed, as you can see, they can actually be placed outside this little third root. Why? Because 3 appears 3 number of times, it pops, and we just get that number. So we end up getting some 3 outside, but we multiply this with third root of 9 over 4. And we haven't learned how to simplify, right? We haven't learned how to simplify this, so we're just going to leave our answer like this, okay? It's okay to leave our answer like this, and if, of course, in Algebra 2, we're going to learn how to simplify, writing down those expressions using something called rationalizing denominator. But right now, we haven't learned about rationalizing denominator, so we won't do it, okay? So it's the whole idea of rationalizing denominator, if you are interested, well, I can tell you that you just have to fill the remaining gap. Well, 2 squared requires extra 2 to be multiplied in the bottom to somehow cancel off all those third roots, right? So that being said, this is what has happened, and we can move on to number 4. Yes, so this will be the answer for our problem, and let's move on to number 4. Okay, so number 4. Bob rides his bike to work, whose office is 10 kilometers from his home. Right, so I think we got to draw the picture, right? So there's a home, and there's a workplace, and the distance between those 2 places are 10 kilometers. Got it. And he rides 12 kilometers per hour. So I would say this would be the rate problems, right? This would be totally the rate problems. And when we get the rate problems, it's very likely that it's going to be direct proportion. Okay, so here we go. 12 kilometers per hour, number 1. 12 kilometer per hour, we can actually indicate that this would be 12 kilometer within 1 hour. Does that make sense? Right, so 12 kilometer within 1 hour. I want to ride 10 kilometer. I want to ride 10 kilometer. How many hours will it require? It's not going to be 1 hour, 1 full hour. It's going to be less than 1 full hour, right? So what do we do? Well, there are multiple ways of handling things. There are multiple ways of figuring things out. Well, if we use just like the ratio, well, I would say this would be 1 kilometer would be 1 over 12 hour, and 10 kilometer would be 10 over 12 hour, and in terms of minutes, it would be 50 minutes. For those people who are interested in figuring out why I got 50, well, you know that 1 hour is just about 60 minutes, right? So 10 over 12 is in fact 60 and 50. So out of those 60 minutes, I'm taking 50 minutes. So it's just apparently it becomes 50 minutes for us. But that's one way of handling things out, right? What about the second way? Something called unit conversion. I would like to talk about some unit conversion. And if you use a unit conversion, you guys will understand that if I write down 10 kilometer, I got to cross out kilometer, guys. I got to cross out kilometer. I got to come up with hour. There's only one way that I can cross out kilometer with hour using that piece of information. We got 12 kilometer and we got 1 hour. And you know the kilometers and kilometers are all crossed out. We get 10 over 12 amount of hour. And apparently that becomes 50 minutes as we saw in the previous line out there. So this is one way of figuring things out, okay? Now, this Bob has to ride 50 minutes in order to somehow reach his workplace. And he has to get to work at 9 a.m. So, you know, like how many, and you can totally think, it's not math here anymore. You got to arrive at 9 o'clock. You're riding about 50 minutes. When would you start riding your bike? When would you start riding his bike? You know, Bob should actually leave his place at 8:10, right? So 8:10. Totally contextual meaning. So that's what's up, all right? So this is number 4 and number 5. Hey guys, welcome back. We're gonna go cover all problems on the skill practice, starting from on page 94, number 1. And if you look at number 1, we have A and B being the basics, right? So A, All right, so we have 2 plus 3x. That is going to be smaller than or greater than or equal to 14. Okay. So these are all basics. We just need to isolate the variables. And in order to isolate the variables, we need to cancel out that 2 by subtracting 2 from the left side and the right side. That means translation. So we got 3x greater than or equal to 12. So x is going to be greater than or equal to 4. But we don't stop here. We may actually graph this. And if you graph this, that means on the real number line, we get something 4. And everything that is straightforward from the right directions is going to be the solutions. So in other words, our answers are going to be somewhere down here. Right? Our answer is going to be somewhere staying down on that region. And I would say, got to start from 4 to infinity. And that would be the answer for our problem. Now, let's just try to look at part B as well. Part B. Now, if you look at part B, we have 2 plus 5x. We get 2 plus 5x smaller than 15 minus 8x. 15 minus 8x. And these are, in fact, 13x and 13. What have we done? We've been adding up by 8x. We've been adding up by 8x, and we've been subtracting by 2 on the left side and the right side. And we end up getting something like this. All right, so x is going to be smaller than 1. So we don't stop here. We got to sketch the real number line. And on the real number line, I want you to open up one open circle at 1. And you got to decide whether we need to color the left side or the right side. Well, check this out. I got to sketch something that is on the left side. Why? Because we need to sketch something that's smaller than 1. So we got to sketch something that is smaller than 1. All right. So that being said, we have from negative infinity all the way to 1. Right. So these are open interval. These are open interval. Right. So we get open and open. And that being said, we will try to move on to 1C. Now, 1C will be the hardest out of the basic format. Right, so here we go. All right, so if you look at 1C, we have conjunctive inequality, again. And conjunctive inequality states out that we need to solve for both common parts between those two, number 1, circle number 1 and circle number 2. And we got to find out the common parts in between those two expressions, right? So we have 10 minus 3x. And that's supposed to be smaller than or equal to 6 minus 4x. And that's 6 plus 4x, my bad. And that shall be smaller than 25 minus 3x. Okay. This is going to be number 1. That's going to be our number 1. This would be number 2. Okay. So number 1. We get 10 minus 3x smaller than or equal to 6 plus 4x. We can play around. And of course, it's going to be best if we let our coefficient of x being positive. So in other words, I think I can push those 3x, negative 3x onto the right side. And eventually we get something like 7x, and that becomes 4. So we get x smaller than, greater than 4 over 7. That's the first set of ideas. Now, what about the second drill? The second drill tells us that we need to solve number 2. 6 plus 4x smaller than 25 minus 3x. I got to say that these are 7 times x minus 19. X got to be smaller than 19 over 7. Now remember that these are all end. These are all end property, right? So in other words, I need to somehow find out the common parts between those sketched part on the real number line. We got some 4 over 7, except that part is going to be colored, and we got some 19 over 7. And remember, 19 over 7 equals 2 and 7 and 5, right? So 2 and 5 over 7. It's going to be quite far away from 4 over 7 because 4 over 7 is going to be staying between 0 and 1. Right. we need to find out the region that is common to both. Region that is common to both. In other words, this should be the region of our interest. So we got some 4 over 7, we got some 4 over 7, and we got some 19 over 7, and we got 4 over 7 and 19 over 7. If I need to write down as of an interval notation, of course I didn't write down the interval notation for the answer key, except for A and B, but you gotta somehow add it up like this. 4 over 7 and 19 over 7 with the open, close, so close-open interval. But when we say close-open interval, it doesn't mean that it's both open and closed. It's neither open nor closed, but normally we call it as close-open interval. All right, so that being said, we move on to number 2. Okay. So number 2 is quite easy now. 5 to the power of 4, 6 to the power of 3, and 7 to the power of 2. Well, you can see that the extended version, extension, will be something like this. 5 to the power of 40, 6 to the power of 30, and 5 to the power of 20. 7 to the power of 20, right? I would say that becomes easy extension. This is easy extension, extension level 1. And if I give you level 2, it will be something like 5 to the power of 28, 6 to the power of 21, and 7 to the power of 14. Okay? It's not something that's quite obvious. But I gotta say that you can say that, oh yeah, the common multiples are gonna be 7, we can pull it out. Well, yeah, that's basically what's gonna happen. All right, so but anyway, I'm gonna say that every answer that we find in the actual answers would be automatically transferred to all of these ideas. So what is this? That's gonna be 625. That's gonna be 216. Those are 49. That's what's gonna happen. There we go. That's what's gonna happen. So if I need to somehow write down in the opposite directions, you can see how I made the problems. I was increasing the base by 1. I was decreasing the top, or I would say the exponents, by 1. But again, you can actually write it down in all directions. All right, so that being said, hey, that's how we solve number 2. Okay, so we're gonna spend some time on 3, 4, 5, and then we finally move on to the next chapter. All right, so we're gonna finish it off at number 5. Don't worry, it's gonna be quite short. I'm gonna spend about just all 20 minutes or so, and we're gonna move on to the next topic. All right, so number 3. On page 95. So number 3. Bob the bibliophile. What's a bibliophile? Bibliophile is like a guy, it's like a person who likes collecting books, or reading books too. Bibliophile has a budget of $230. He loves buying books. Assume he will buy as many books as he can, and the books Bob will buy each cost $17. At most, how many books can Bob afford and still have at least $25 left? Right. So this is everything about mathematical modeling. Okay. And mathematical modeling, the easiest form of mathematical modeling, even though the title says, oh yeah, this is going to be mathematical modeling. No, it's not. It's quite easy. So we got $230, right? We got $230 right now. And each of the time, got to say that we need to somehow come up with the, I think we got to come up with some variable, right? Set n as a variable. So what's that variable? It's the number of books, as you can see. These are number of books. Now, number of books cannot be bought. All right, everyone, let's begin on page 144. All right, so on page 144, I want you to look at number 7. All right, here we go. Number 7, we have solve each of the following equations by completing the square. And I got A, which is going to be
which is going to be nice. X squared plus, was it plus or? Yes, plus 2x plus 13 equals 0. Okay? So we got x squared plus 2x plus 13 equals 0. We have x squared plus 2x, which is going to be negative 13. And we have x squared plus 2x, and I'm adding a Mr. Square right here. And I'm also adding the same Mr. Square onto the right side as well. All right? So we have x squared plus 2x plus 1. Plus 1. Why? Because you divide that little 2 by 2 and take a square. And we end up getting the same value, and we get x squared plus 2x plus 1, which is going to be negative 12. And we got x plus 1 squared is in fact negative 12. So you can see that x plus 1, in fact, plus minus roots negative 12, and x is in fact negative 1 plus minus roots negative 12, but we don't leave negative 12 as it is. We got to somehow switch those negative 1, roots negative 1, into I. Remember the baby Groot. All right, so we have negative 1 plus minus roots negative 1, roots 12. And in fact, negative 1 plus minus I times 2 roots 3. Negative 1 plus minus I times 2 roots 3. And that becomes the answer for this problem. All right, so hey, that's the answer for 7a. And what if we try to solve these type of b using completing the square? All right, so how do I solve these b? All right, so let's see what happens for number b, part b. We get 12x squared minus 11x minus 11x minus 36 equals 0. Okay. All right, so I don't want 12 inside. I don't want 12 inside. So what I'm going to do is that I'm going to take out all those 12. But here we got two possible options. We divide everything by 12, where we probably pull out 12. In this case, since we're interested in finding just the values of x, we're just going to take out, or divide everything out by 12. So we have an interesting number, x squared minus 11 out of 12x minus 3 equals 0. It's never an interesting thing. 11 out of 12 is a weird looking fraction. We don't want to deal with this, but we got to try out solving this using the completing the square. So we got x squared minus 11 out of 12x plus Mr. Square, and we got 3 plus Mr. Square. So we have negative 11 out of 12, and if we got negative 11 out of 12 divided out by 2, which would be negative 11 out of 24, and we get negative 11 out of 24 squared, in fact, 121 divided out by 576 though. Now that would be 121 divided out by 576, 121 divided out by 576 out there. All right, so we got x squared minus 11 out of 12x. Well, the whole process, in fact, will turn the left side into x minus 11 out of 24 squared is in fact 3 plus 121 divided out by 576 though. All right, so I got to think about what happens for 3 times 576, because I really hope that this whole process on the right side, the number that I see right now, turns into a perfect square. If not, then oh man, we got a long way to go, right? So we got 576 times 3, and if you multiply this out, these are 18, and we got 2, and we got 17, so 1728 plus 121. And if you add them up, 1849. I think 1849 somehow rings a bell. 1849 divided out by 576. 1849. What is this? Like, we got some like 40, probably like something like 45 squared is 2025. What about 43 squared? Let's just try to think about 43 squared. If you think about 43 squared, that becomes 9 and 1, 2, and 2. Whoa, so that becomes 171849. So in fact, that turns out to be 43 squared, right? So that's a 24 squared, and we got 43 squared. And if you were to figure out what happens out in the perfect square, we got x minus 11 out of 24 squared, which is going to be 43 divided out by 24 squared. And if I just use the fact about plus minus square root something, then we end up getting x minus 11 out of 24 being plus minus 43 out of 24. And if I just use some kind of like a simplification, 11 out of 24 plus 43 out of 24. And at the same time, we got something like 11 out of 24 minus 43 out of 24. And if you use all of these facts, these are 54 out of 48 though, and we end up getting something like negative 32 divided out by 24. And if you simplify, 24, right? So if we simplify this, these are 6 times 9 and 6 times 4, and we cross it out, I think we end up getting 9 out of 4. But at the same time, these are going to be something like negative 4 out of 3. And in fact, this is how we solve, right? This is pretty much how we solve the questions. And I think, yes, we end up getting 9 out of 4 and negative 4 out of 3. Well, we got an answer for this part B. I think easier part would have been just like factorizations. Easier part would have been factorizing something like 4x and 3x. And if you use the answer choices, it would have been 4 and 9. And probably something like plus and minus. So it would have been minus and plus. So in fact, x would have been 9 out of 4 and x would have been negative 4 out of 3 based upon that factorizations. But we were not using factorizations to solve this number 7. So there we go. All right. So now on page 144, we did this number 7 right now. I actually want to move on to page 145. And on page 145, yes, I got to talk about some quadratic formula. Whew. All right. So page 145. It's everything in this section has to do with something quadratic formula. We're going to deduce this, all right? So number 8 is going to show you how to deduce quadratic formula. All right, so how to deduce quadratic formula. What is this? Like these are ax squared plus bx plus c, which is going to be 0. And we understand that a is not equal to 0. A isn't equal to 0. So where a is not equal to 0. So if a is not equal to 0, hey, think about what we do. Divide everything by a. Why? Because we don't want anything in front of x squared to be non-1, something like not 1. So I want to make everything in front of x squared as 1. So the only way to do so is to divide everything out by a. So we got x squared plus b out of a, x plus c out of a, which is going to be 0. All right, that's going to be positive sign. This is going to be plus sign. So that's going to be plus sign. So we got b out of a, x plus c out of a. All right, so I'm going to move I'm going to move c out of a onto the right side by subtracting c out of a as using the translation property. We end up getting x squared plus b out of ax, which is going to be negative c out of a. Okay, so we're going to add Mr. Square. All right, so we're going to find Mr. Square and see what happens. X squared plus b out of ax. And I'm adding some Mr. Square, but if you think about Mr. Square, we divide the coefficient in front of x by 2, which is going to be b out of 2a, and we square that. So this would pretty much be squared out of 4a squared. And in fact, that's going to be negative c out of a plus b squared out of 4a squared. And I really wanted to somehow combine all of these forms into a nice looking single fractions. In order to do so, I need to multiply 4a in the bottom and I need to multiply 4a on top. So if I multiply 4a in the bottom and top, I think I end up getting 4a squared in the bottom, but the numerator is going to be b squared minus 4ac. So we have negative 4ac. I'm just going to write out everything of what I just told you right now because I'm just kind of like wrapping it so fast, right? So these are like 4a squared and I got b squared minus 4ac. Why? Because these are the single fractions. We get the common denominator. If you have a common denominator, we can actually group them into a single denominator. Then we got b squared minus 4ac out of 4a squared. All right, so what happens on the left side? Try to look at the left side. We got x squared plus b out of ax and plus b squared out of 4a squared. That will turn into b out of 2a squared. All right, so we end up getting x plus b out of 2a squared, which turns out to be b squared minus 4ac, divided out by 4a squared. And all I got to do is just to figure out that's some kind of a square, a little blurb squared, right? Okay, so x plus 2a. X plus b out of 2a, my bad, plus minus square root of b squared minus 4ac divided out by 4a squared. Now, what do you know about square root of 4a squared? I think that the square root of 4a squared will turn into 2a, in fact, and this would be plus minus. We get 2a in the bottom, and we got b squared. Hey everyone, welcome back. We're gonna cover all problems in the skill practice of this topic number 11. All right, so here we go. So I just want you to look at from page 172. all the way, all right? So up to skill practices. I want you to look at number 1, okay? So number 1. So how did you try this? Well, the parabola shown below is the graph of the equation. Apparently, there's the equation, there's the graph that looks like this, which is going to be x equals ay squared plus by plus c. And apparently, you just need to find out where what the value of a plus b plus c. So the value of a plus b plus c apparently occurs when y equals 1. So this occurred at y equals 1. So you can see that the x value will appear when y equals 1. And I want you to look at when y equals 1, we end up getting the vertex though. We end up getting the vertex, and I want you to think about that x value would be in fact -3. So on the grid, we get -3, 1. That's supposed to be the value of this one. All right, so that's the answer for this number 1. So here's what's up. If you were to find out the leading, the sum of the coefficients, sometimes you might be asked about sum of the coefficients, okay? I think I need to write down sum of coefficients. And if you need to find out the sum of coefficients, well, then you just plug in either x equals 1 or y equals 1. Especially for this right side, you just have to plug y equals 1, right? Okay, so that being said, we move on to number 2. All right, so here we go. Number 2. It says how many y-intercepts? We need to find out the y-intercepts. Y-intercepts does the graph of the parabola x equals 2y squared minus 3y. Is it plus 7? Yes. All right. So what is the y-intercepts? Y-intercepts are the values of y-coordinates such that the curve intersects with the y-axis. It gotta be real. Y-intercept gotta be real. So y-intercept are all real. So all real. And at the same time, this gets occurred when x equals 0. So you plug in x equals 0 to find out what happens. So I plugged x equals 0. I plugged x equals 0. Let's try to find out that 2y squared minus 3 times y plus 7, in fact, would give me some kind of like real values of y. In order to do so, I'm solving for b squared minus 4ac. And b squared minus 4ac tells us that -3 squared minus 4 times 2 times 7. So in other words, 9 minus, is that 8 times 70, is that 14, so 56. This is less than 0, totally less than 0. So if it is less than 0, we get no real solution. It has no real value of y. So because it has no real value of y, it means that there's no y-intercept. So paraphrasable, no y-intercept. Does that make sense? It makes sense. Why? Because if you think about the sketch of the graph, it would be in fact probably somewhere down there. Okay? All right. You don't have to know about specifics about graphing it, but we can understand what it means for having no y-intercepts. Now moving on to number 3 though, okay? Number 3. As shown in the figure below, the zeros are passing through the zeros of the quadratic that passes through our m and n. All right, so we have the sketch of the graph. And I would say, even though it's not marked properly in the picture, we get m and we get n, okay? So we understood that these are the vertices, vertex, 2, -4. Now there's going to be 4, 12. Okay. So step 1. I'm assuming that you guys have tried these problems already. First off, guys, we know that the vertex stays at 2, -4. If it stays at 2, -4, I gotta say y equals a times x minus 2 squared minus 4. And at the same time, it passes through 4, 12. It passes through 4, 12. So a times 4 minus 2 squared minus 4. And in fact, these are 16 and a times 2 squared. So 16 equals 4 times a. So a equals 4. So a equals 4. So apparently these are the possible values that we have found. All right, so guys, step number 2. What are we looking for? I think that we're looking for the values of m and n. M squared and n squared. All right. All right. Y equals 4 times x minus 2 squared minus 4. Okay. So if I were to solve this by setting, like by figuring out what m and n are, I think that we got to plug y equals 0. So we have found 4 times x minus 2 squared minus 4. So these are 4 equals 4 times x minus 2 squared. And at the same time, you can cross this out. We get 1 equals x minus 2 squared. So in fact, 1 plus minus 1 equals x minus 2. So x equals 2 plus minus 1. So you can see that x equals 3 or 1. What are we looking for? One of the values are going to be 3 and the other would be 1. So I got to say these are 3 and that must be 1. So in fact, m squared plus n squared supposed to be 3 squared plus 1 squared. These are just 10, all right? So that's the answer for this given problem. All right, so we move on to number 4, okay? We move on to number 4. So number 4, for what value of k does the equation x squared plus 10x plus y squared minus plus 6y minus k represent a circle of radius 6? Okay. X squared plus 10x plus y squared plus 6 times y? Yes. Equals k. Let me just write down as equals k. I'm adding a special number onto the x's and y's such that it becomes a perfect square. So we have found x squared plus 10x plus 25, y, because you can see that you divide 10 by 2 and you take a square. And we get y squared plus 6 times y plus 9, because you divide 6 by 2 and take a square. And it all becomes something like 34 plus k though. Why 34 plus k? Because you're adding up 25 and 9 and it becomes 34, and you add up 34 onto the right side and you add up k. So it becomes x plus 5 squared and plus y plus 3 squared. And these are in fact 34 plus k. So you can see that these are 6 squared. These are all 6 squared. Why? Because the question told you that the radius is supposed to be 6. So in other words, 34 plus k is supposed to be 36. So k is supposed to be 2. There we go. We have found the answer for this given problem. All right, so we need to cover 6 more problems, and I think I can cover this. Number 5 would be kind of like challenging, right? Number 5 would be kind of challenging, but we can still manage to do so. Number 5. Let's put a star, okay? Let's put a star. So we got a circle centered at 2, -1 with the radius of 4. So I found x plus 2 squared, x minus 2 squared, right? Is it x minus 2 squared? Yes. X minus 2 squared plus y plus 1 squared. Apparently that becomes the radius of 4. That's supposed to be 4 squared, 16. That's the first equation, a paraphrase of the first sentence. And it intersects the circle centered at 2, 5. 2, 5. So y minus 5 squared. In fact, that turns out to be the radius of root 10. Radius of root 10 means that root 10 squared is supposed to be just 10. Okay. So I want you to just think about solving this equation and to find out the points of intersections between A and B. Okay, so here we go. This is what we're going to do. I'm going to subtract these two, okay? I'm going to subtract these two. I'm going to consider these as the same term, x minus 2 squared and x minus 2 squared. Why? Because it looks... Hello everyone, welcome back. We're going to cover problems from number 2
So I think that's going to be 6, right? On page 216 to page 219. Right, so let me just write it down, right? So there's going to be page 216 all the way to 219. And these are all skill practice questions. You should have been able to finish this by yourself. However, I can tell you number 3 would have been hard. Number 4 would have been extremely hard. Now, we cover the easiest problem right now, number 2. Okay? So you look at number 2, A, it's kind of like easy though, because we need to find out f of 2. At x equals 2, draw the vertical lines. And f of 2 is in fact what? You find the y value of 4, right? You find the y value of 4. But what about like f of 4? Right, so B would be f of 4. Now, first off, if you just draw a vertical line at x equals 4, you end up getting y value of 2. So you got to start from like computing from inside, right? So f of 2, and in fact, that becomes 4 by A. Right, so these are the answers for the first 2 parts, and let's just move on to part C. Okay? So C would be kind of nice. We need to find out f of x equals 3. Okay, so f of x equals 3. It means that somebody actually gave me the horizontal line. So that's going to be y equals 3. Y equals 3 means that we get the horizontal line. And if you draw the horizontal line at y equals 3, let's see what happens. You literally draw y equals 3 and you find the number of intersections is 3 points. In fact, you conclude that there are 3 values of x, or I gotta say 3 values of intersection points. Right, so the answer becomes 3. What about D? If you look at part D, it says state whether the function y equals f of x has an inverse function. In order to tell whether we get an inverse function, it must pass through the horizontal line test, as we've seen last time, right? So horizontal line test. Perform the horizontal line test, it fails. Dramatically, it fails, right? It actually fails the horizontal line test. It means that we don't have any inverse function. So no inverse function. No inverse function. Okay, so that's how we solve number 2. Okay, but we're gonna move on to number 3. In order to solve number 3, I think I need to draw the horizontal, the original graph. Okay, so here we go. We're hitting number 3 out there, and the original graph. Well, let's see. We start from -2, 1, and we reach 0, 1, and we need to draw these V-shape graph. All right, so let me mark this out. Okay, so these are 2, 1, and these are 1, -1. That's gonna be 0, 1, and these are -2, 1. All right, so we have these original graph, right? I'm not sure how we're gonna, like play with this, but we have these rules. All right, so A. So one at a time. So if you look at A, we end up getting y equals 2 times f minus x. Well, we call it -x plus 1. All right, so 2 times f of -x plus 1. What is this? How do we solve this, right? So we got to understand what's going on here. That's a vertical stretch, These are known as vertical stretch by a factor of 2. And we understand that that negative that we see here would be right in front of x. We got to think about the counterintuitive. We got to think about the opposite case. If you put negative in front of x, it's going to be reflection about the line y-axis, right? So reflection about the y-axis. Reflection about the y-axis. And how about this one? That's like up by 1. Hooray. So think about it this way. We're going to do it all together. I'm going to vertically stretch this so that it becomes like somebody's pulling it, stretching from the ground, right? The x-axis. And then we're going to reflect it about the y-axis, and we're going to push it up by 1. So 1 by 1, okay? 1 by 1.
think about it this way. You don't write this full picture right now at the moment, but what happens is that we vertically stretch this by a factor of 2. So it becomes a little bit longer picture. And then what happens is that we reflect it about the y-axis and we push it up by 1, right? So if you push it up by 1, let's see what happens. Right. So the final graph. So the final graph should start from -2, 3. So we got to go from -2, 3, and it falls down somewhere, and right there. Okay, so we have -2, 3. We get 2, 3. We get 0, 3. And these are going to be -1, 1. So that the whole length, the V length, it's just going to be 4, not 2. All right, so this is how we actually graph the answer for A. Okay, so we move on to part B. All right. So still remember the original picture, okay? Okay. So if you look at B, we get y equals -2, is it negative? Yes, negative f of 2 minus x, and we're adding it up by 1 again, right? So remember that this is not the original way to interpret the given function. We should fix this a little bit. How do we fix this? Well, this is how we fix, okay? This is how we fix. You always need 2 layers of parentheses. Whenever you interpret the transformation of a given function, especially as you move on all the way to not just limited to Algebra 1, but Algebra 2 and pre-calculus, if you were to learn how to perform the transformation, you always remember that we get 2 layers of differences. All right, so 2 layers, not differences, 2 layers of parentheses. That is outside f though. Normally f of x equals y. Now, that means we're putting negative in front of y. It means a reflection about the x-axis. Reflection about the x-axis. About the x-axis. And how about this one? This would be reflection about the y-axis. That's right, the y-axis. Now, what happens to this -2 though? If you think about that little -2, it means that we're moving right by 2. It's always counterintuitive. Translation is always counterintuitive. Shifting is always counterintuitive, right? Especially for x. So that would be right by 2. How about this one? That's going to be up by 1. Right. So again, I got lots of questions. I mean, like, not lots of questions, but I got some like important questions. That was crucial though. The crucial question on the questionnaire, people posting up on those, like, the Q&A, and I found this reflection about the x-axis and all these points, and a person, like a student, try to ask why we should perform reflection first, not about translation. But again, you can actually perform translation first, but you always got to think about whether we have to change everything altogether. So here we go. If you mix up reflection about the x-axis and the y-axis first, if you combine these two, it means reflection about the origin, okay? Reflection about the origin. About the origin. So it means that if I give you some kind of canonical picture, and I think I gave you this picture already. I think I explained this concept in a bullet points. Let me see. I think I have explained this concept in a page 208 on the 3rd bullet point, reflection about the origin. If you get negative and negative, just like this following form, then we usually call this as a reflection about the origin. So I explained it in page 208 though, on the 3rd bullet point. Now, I want you to look at this particular case about performing the reflection, then translation. So, here's the picture, okay? If you reflected about these things, that picture, about the origin, then you choose the origin and you somehow rotate this about 180 degree, counterclockwise, clockwise, doesn't matter. But we end up getting these type of picture, okay? These pictures, right?